Today we're talking about work. So last class we discussed the intro into energy. So we talked about the three types of energy a system could possibly have. If it includes an object, it can have kinetic energy. If it includes the earth, it can also have potential energy. If it includes a spring, it can also have spring potential energy. So we really talked about isolated systems and the energy that they already have. So we went with those little monsters that sprung up off the table. We said that they started with spring potential energy. As they got to their highest point, that all turned into gravitational potential energy. And then as it fell back down, it turned all into kinetic energy. Well, one question we didn't ask is how did the little monster get energy to begin with? Because the actual monster all by itself, let me go grab one. The actual little monster, just sitting here, has no energy. It's not going to spring up and jump. It has nothing at all. So its energy bar chart would include no energy at all. So there must be some way that this isolated spring monster Earth system must get energy added into it. And the way that's going to work is that I press down on it. Now the spring is compressed, so it has spring potential energy. Eventually it's going to pop up and turn that spring potential energy into kinetic and gravitational potential. And then it'll fall back down, turning it all into kinetic energy. But then it stops moving. And it's, oh man, and it's no longer compressed. And now this object isn't going to move anymore. So where'd the energy go? Right now its energy bar graph would again be 0. So let's talk about that. Work is done when a force is applied over a distance. So this is a force. It would have to be a net force. If there are balanced forces, then each individual force can do work, but the amount of work it's going to do will be equal and in opposite directions. For example, if I currently have Fg and Fn in equal amounts, and let's say I travel a distance down of 10 meters, right? The normal force, if it's equal to Fn and Fg are equal, so it's at constant velocity, let's say. Fn is going to do an amount of work in the positive direction. Fn is positive. The direction it traveled was negative, so the work done by this would be equal to negative 10 mg, because we said Fn is equal to mg. That's the work done by the normal force. The work done by the force due to gravity would be Fg times negative 10. Fg is in the negative direction. So the work would be equal to negative times a negative 10 mg. So the total work would be those two combined, the work done by Fn plus the work done by Fg. That would be negative 10 mg plus 10 mg. The work done by balanced forces would be 0. So when I say a force needs to be applied over a distance, that force has to be unbalanced. There has to be a net force acting on the object, otherwise nothing happens. We're going to come back to this example in a little bit, but keep that in mind for now. The other thing we needed was a distance. So work is only done if that force is applied over a distance, not over a time, over a distance. So right now I'm going to apply a force to this table. So I'm pushing on it really, really hard. I've pushed on it for a while now, at least a couple of seconds. Now I'm on 10 seconds, 15 seconds. I'm pushing on this, but no work is being done to the desk because it did not go a distance. That's a really important thing. This is a distance traveled. All right, so work is done, force multiplied by distance. Now you'll notice from that very first example, directions matter. So typically, work will be positive if I have a positive force and a positive direction, or a negative force and a negative direction. Put the slash there. Work will be negative when I have a negative force and a positive direction, or a positive force and a negative direction. So the work due to gravity was positive because the direction of the force was negative, gravity goes down, and the direction my object traveled was negative. So the work due to gravity was positive, sorry. The work due to the normal force was positive, and the distance it traveled was negative, so therefore negative work was done. And those two things canceled out. Now let's talk for a second about what can do work to an object. Only forces external to the system can do work to an object. So this is really important. Let's talk about that first example again. I lowered an object down, let's say, to the ground. So let's flush this out more. This was the ground. I had a crane holding an object that was providing, I guess not normal force, a tension force. And it lowered the object down at constant velocity to the ground. Okay? So if my system is just this box, then the only possible energy this system can have is kinetic. So this would be at the beginning, this would be at the end. It's moving at constant velocity the entire time, so however much kinetic energy it had at the beginning is the kinetic energy it had at the end. There was no change in energy to the system. That's because there was positive work done by gravity and negative work done by the normal force in equal amounts, so they canceled, and nothing changed. But if I slightly change my system, now I say my system is a box Earth system. Now, because I have Earth in my system, I can have kinetic energy and UG. So, starting up above this 0 location, I know I have some kinetic energy because it's moving at constant velocity, and I have some UG. At the end, I'm still moving at that constant velocity, but I have no UG. Well, where did the energy go? Well, don't forget that external forces do work to the system. The only external force this time is that normal force. Sorry, this is a crane, so it's the tension force. I'll fix that. Tension. Now, if it's a box Earth system, the only force that could act on it and do work to the box is that work from the force of tension. There's no work from the force of gravity because gravity is now included in my system. My system is box and Earth, so gravity is now a force that's inside my system. So now, the only thing that affected it was the work from the tension force, and so my total energy decreased, right? External work was done to my system. And the first way we looked at it with just the box, the work stayed the same because both gravity and tension did work to my system. They were both external forces, and so the total energy didn't change. Let's look at another example of this. Let's say instead of having a box floating over the ground, we have a box being pushed, and there's friction. So I'm going to push this box a distance of 10 meters. Now here, I can make it a box earth system or a box system. Either way, this is starting on the flat ground, so it's not going to have any UG. Like, that's not going to happen. So when it starts, let's say it starts at rest. So it has no kinetic energy and no gravitational potential energy. I'm going to push it all the way to the end, and when it gets here, it is also at rest.